This is Ethan Port from TIBCO Software. In this movie, we continue using ASOperations to predict the behavior of space operations. But now, we will bundle space operations together into all-or-nothing transactions. In the previous movie, we started 5 Metaspace members, the ASOperations process, an ASAdmin process, 2 ASAgent seeder processes, and an ASMM server. We performed several space operations to put, get, and take data tuples from the MySpace space. In the end, there was a single tuple left in the space with key equals 100. Also notice this tuple is seeded by agent 2. We will return to this fact later in the demonstration. All these operations were recorded in the ASMM space statistics and in the historical stats chart. Now type B in ASOperations to begin a transaction that will bundle together an all-or-nothing block of space operations. First, we put a tuple with key equals 500 and a value equal to 500. Next, put 2 more tuples with key and value equal to 600, and then another tuple with key and value equal to 700. In another movie, you will see that other member processes will not see this change until the transaction is committed. But because ASMM uses special internal API, it is actually able to reflect the pending put operations still in its prepare phase, and visually reflect this pending change to the MySpace space even before the transaction commits. This behavior also demonstrates that ActiveSpaces transactions are distributed and global, so each seeder for a particular tuple value prepares changes from the space operation. This indicates the network and processing impact to carry out transactions is optimized, and when ASOperations commits the transaction, all the changes are quickly committed by each seeder in a distributed manner. Inside the transaction, changes are accumulated and reflected in a consistent way. So for example, when we update the key equals 700 to a new value equals the string new value, the new value is also visible to the ASMM monitor, but is not visible outside the transaction. Again, distributed locking will prevent dirty reads of these changes by other member processes until this transaction is committed. When we get the key equals 700, we see the current updated value, new value, is returned. We put another key equals 800, value equals 800 tuple. Now we are in the process of preparing a take operation, but instead of completing this operation, we simulate a runtime failure by killing the ASOperations process in the middle of the transaction. Console messages are reported by other members that a pending transaction is in trouble. We restart the ASOperations process, but the transaction is already abandoned. Notice there is no data loss of committed data because ASOperations is a leech for the MySpace space, and also the space is replicated, but the distributed transactional semantics automatically remove any non-committed changes to the MySpace space. ASMM reflects that the transaction is automatically rolled back and the space is reset to the pre-transaction state, with just the single tuple with key equals 100 in the space. Also notice that the same seeder, agent 2, seeds this tuple. Now that the ASOperations has restarted, begin another transaction. We perform some more space operations. When we get the key equals 100, we see the pre-transaction tuple is still in the space. Now we take this tuple out of the space. The take also is reflected in the ASMM even though it is not visible outside the transaction until this transaction commits. When we get the other key values from the previous transaction, we verify that we see in ASMM that all the changes in the first transaction have been rolled back. Now put 2 more tuples into the space. Each of these happens to be seeded by the first ASAgent seeder. If we commit the transaction, all these changes will then become visible to any member. Instead, let's roll back the transaction. So instead of abandoning the transaction like we did in the first transaction, in this use case, we deliberately issue a rollback signal, perhaps due to some other logic in another part of our program. We see the same behavior as with the first transaction, in that all the changes are automatically rolled back, but now no console messages are printed out by the other members. After the transaction rolls back, when we get the key equals 100 tuple, we see the take operation was rolled back, so the tuple with key equals 100 is back in the space after the take operation was rolled back, and that the tuple with key equals 60 does not exist. In this movie, you learn to predict the behavior when space operations are bundled together into all-or-nothing transaction blocks. You saw that transactions keep a consistent view of tuples across all the distributed seeders, and transactions will roll back either when the member process owning the transaction fails or when the process explicitly issues a rollback command. You can find more training material and other resources at activespaces.tibco.com, and you can communicate with other TIBCO users at tibcommunity.com, and you can find other training options at 10.tibco.com. Thanks for watching.